FBI data, 24.9% of robberies are cleared with arrests. A new detective is assigned to 10 different robberies. What is the probability that the detective clears all 10 robberies with arrests? Well, the idea is the probability of each of the 10 robberies being cleared is the 24.9%. But the problem is I don't want just the probability for one robbery. I need all 10. So what it would look like here is we would have the 24.9% as a decimal. Well, the 24.9% would turn into 0.249. Then to make sure that it's happening for not just one, which is what the 0.249 alone is, but then to include all 10, then we're going to raise it to the 10th power, making sure that we have 10 of these 0.249s multiplied together. So we take our 0.249 and raise it to the 10th power. And depending on your calculator and how it calculates, you'll probably get something that looks like the following out of it. You'll get something like 9.16, a bunch of other numbers, and then an E and a negative 1, 2, 3, 4, 5, 6, 7, a negative 7, which remember is scientific notation for 9.16 times 10 to the negative 7th. Now I do expect that you know how to turn this in or convert it into a regular decimal. Remember the negative 7 tells you that you're going to move your decimal place 7 places to the left, so that you would jump your 9 and then add 6 more places, which would all be placed with zeros, so it'd be 0.000000916. And that would be your final answer that you would input to my math lab. Now, on the next one, they ask a follow-up question. What if none of the 10 robberies were cleared? Well, we know that the probability of just clearing one robbery is the 24.9%. So what would be the probability or chances of you not clearing the robbery with an arrest? So not clearing would be the rest. Everybody, we'd subtract that from 100 and we get the 75.1%. And again, just like before, we'd want to convert that into a decimal, which would be 0.751. And just like before, we want none of the 10 to be cleared with arrest, so we'd raise it to the 10th power. So when we do the 0.75 to the 10th, we end up getting the final answer of 0.057. And that is our probability for clearing none of the 10 robberies with arrests. Now let's take a look at problem C. What is the probability that the detective clears at least one? So this one is different because we're seeing the at least one here. That means we're going to be wanting to take the complement of something. So we want to list out the sample space. I'm going to shorten it to SS so I don't run out of space here. And what are my options? Well, we're talking about clearing with an arrest, so it could be that none cleared with an arrest. We're talking about up to 10. It could be 1 through 9 were cleared with arrest. And it could be all 10 were cleared. And I just overly simplified this just to make my life a little bit easier when I listed out the sample space. In this particular one, though, I want that at least one was cleared with an arrest. So either 1 through 9 was cleared or even all 10 were cleared. That's what I want. And this one is definitely a good way to see that this would be a real pain. Because if you wanted to find all these probabilities by hand, you'd be looking at finding what's the probability of clearing one arrest. Well, what if it was the first one, or the second one, or the third one, or the fourth one? And you have to add up all those possibilities. It's just a pain. So instead of worrying about that, what we'll do is, again, do what we don't want first. Its complement. We'll find the probability of clearing none of them. Well, we actually did this. The probability of clearing none of them with arrest, which was what we did in problem B, which we got, what value? We got 0.057. What that means is what I do want will be its complement, which will be 1 minus what I got from problem B, which will be the 1 minus 0.057, which will give us 0.943. And that's it.